Hello everyone. So on the assignment for sketching trig functions, we're going to start pushing things around. Your basic formula for sine is going to look like a sine b theta minus c plus d. And as we talked about in class, what these two things do, all the ones you're going to get initially, this is going to be worth 1. So for all intents and purposes, for all the ones in your homework, this isn't going to be there. And then A determines your amplitude. Actually, it's the absolute value of A, determines your height. C moves it left to right, and you read this opposite of what it is. D moves it up to down, and you read that the same, just like you did for all the other graphs you guys started learning back since Algebra 2. Sketching sine function first. I think it's helpful if you look at its amplitude, because this is 1, and you're in charge of making the graphs. I'm going to call that 1 and -1. I think it's helpful if you trap it, you draw some horizontal lines to trap the graph in between. Now, these aren't actually a part of it, and as I start trapping these, you guys will get a better sense of what I mean and why I'm doing those. So for no other reason, just bear with me for the time being. Sine graph, how about the corners of the unit circle? So the 4 corners. At 0, you're at 0. Oh, I guess we should scale it. How about you're in charge of it? I'm going to make this thing 1 full period. So I'm going to go all the way out to 2 pi and -2 pi. Okay? So halfway in between is going to be pi, or in this case, -pi and pi. Okay? And then you'd have pi over 2 and so on. 3 pi over 2. I do think you guys do need to label some of this. You don't need to label every single value on the unit circle. I get it. It's time consuming. I got it. I'm with you. Okay? At 0, you're at 0. At 90, you're all the way up at 1. At pi, you're back at 0. At 3 pi over 2, you're down at -1. And here you're back at 0 again. And the same pattern repeats. -pi or 2 pi, you're here. At -3 pi over 2, you're up at 1. This, you're back at 0. This one, you're down at -1, and then you're back there. So to sketch it, remember it's not a V, it's not a heart rate monitor, you're not going peak to valley, okay? It's a curve, okay? So it's not a seismograph, you're not going bam, 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 okay? No, they're curves, okay? I realize it's a sketch, but they're curves, okay? This says it's going to be the same graph, but it's going to be shifted left pi over 4. Or in other words, it's going to be pushed left 45 degrees. Now I'm going to start it doing it the same way I did before. I know this sucker is going to be trapped between -1 and 1. And I'm choosing that height to be 1. I'm choosing this height to be -1. Okay? If you want to make 1 all the way up here and -1 all the way down there, by all means go for it. Or if you want it here and here. You're making the graph. You're in charge of it. You do what you think feels right. I'm going to graph all the way out here to 2 pi, -2 pi. Halfway is going to be -pi, -3 pi over 2. It's going to be -pi over 2. There's going to be pi. There's going to be pi over 2 and 3 pi over 2. Okay? Now to go to graph it, I guess I'm going to go ahead and put these normal points on there to help you see it. Normally I'm here, 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 here. I know some of these are having a hard time showing up because I'm drawing black on black, but I think you can still see it. Now, this says this piece that's been added in here, the C, has pushed it left, because you read it opposite, 45 degrees. Okay, so all these points are going to be shifted left. You know where it was originally, now you just modify it. If this distance is 90 degrees, that much is 45. So I have to shift all of these units left by that amount. And then you graph it. Whoa. Got carried away. I apologize for that. And there's your graph. Except for this lovely little doodad there. Okay. So that's how you graph it. You know where the parent is, read the change on it, and then draw the graph. Okay. Let's try this one down here. This says your amplitude is 2. So that's going to be the distance from the center line to the peak and to the valley. So again, you're in charge of graphing it. I'm going to call that 1, 2. I'm going to call that 1, 2. So negative 2. So I'm going to draw these lines to trap it and to help you see the trapping. Okay, I'm a little bit off. Okay. Normally, you're going to start center line 0, up 1, center line, down 1, back to the center line. Because of the negative, I guess I should draw a scale on there. I apologize, got ahead of myself. Negative 2 pi, so there's negative pi, negative 3 pi over 2, negative pi over 2, so then that would be pi over 2, 3 pi over 2. Okay? Let me switch color there. Okay. Normally you'd start in the center, which is true. The 0 is going to be still 0. The center line is still going to be on the center line at those values. Those are still there. And normally you'd start going up, and you go up to 1. But because of this negative value that's here, instead of starting going up, you're going to start by going down. So this halfway in between point, you're going to be all the way at the bottom. Back to 0, halfway in between, you're going to be all the way up. You're going to start here, you're going to go down, back to center, up, and there's your graph. So with sine, when A is negative, you start going down rather than going up. Okay, so there's your graph. Okay, where you scale this to be is your call. You're in charge of graphing it, so you scale it how you see it fit. Okay, all right, switch to cosine. Cosine, I'm going to trap it same as I did before, negative 1 to 1. So 2 pi, halfway in between is pi, 3 pi over 2, I'm a little far left there, pi over 2, negative pi over 2, negative 3 pi over 2, and negative 2 pi. Okay? Cosine, you're going to do the same four corners. Cosine starts at 1, goes to 0. Starts at, oops, you're going to trap it between the horizontal lines, just like we did for sines and cosines. Or sine. All right, let me switch color then. How about I go to black? Okay, you're going to start at 1, go to 0, go to negative 1, go back to 0, go back up to 1. Start at 1, go to 0, go to negative 1, go back to 0, back up to 1. So here's the cosine graph. The parent cosine graph. The one that all the cosine graphs you're going to draw are going to be modified from. It's like saying this is your parent graph. Okay, for parabolas. All other parabolas get modified off of that. So there's your parent cosine graph. It starts up, goes down, ends up. Okay. So this one, your scale is still 2 pi, pi. Again, I'm a little far left on that. Negative pi, weeks. Negative pi over 2. I'm a little far left for all these. Sorry about that. Negative 2 pi. You're going to trap it between 1 and negative 1. So where you draw the 1 and negative 1 is up to you. So I'm going to trap it between here and here. Okay? They've all been shifted left 45 degrees, or pi over 4. So I'm going to do where they're supposed to be first and then mark where they are now. You're supposed to start up, end up. Halfway in between you're at 0, halfway between those you're back at 0. Start up, end up, halfway between you're down, halfway between those you're on your center line. That's where the parent graph is supposed to be. But this thing got shifted left 45 degrees. So I'm going to move all these points, oops, sorry, right, oops, I read it wrong, oops, You read it opposite. It got shifted right 45 degrees. Sorry for the mistake. So I'm going to shift all of these. Remember, if that's 90, that much is 45. So I'm going to shift all of them 45 degrees right. And it's okay, I went off the graph. That's fine. It's not that big a deal. So I'm going to start here, go down, and I'm aiming at the blue ones. So I found the initial points, or where they are normally on the parent graph. So this one would then just convention off and be over there. Okay. I found the red ones where it normally is, and then altered it by shifting it whichever direction I told you to shift it, and then drew it in. Okay. Parent graph, its amplitude is only a half, and it's negative. So that means it's been flipped over the horizontal axis. Okay. You're in charge of graphing it. I know I normally have said that's 1 and -1, but hey, you're in charge of it, so how about we call it -1/2 and a half? If you want to make marks there and call that the half, that's totally up to you. I'm going to trap it between these two lines. I'm in charge of this graph, so that's what I'm calling my halves. Okay, a little bit low there. Mark where it normally starts. Oops, I suppose I should put the scale on it. 2 pi, pi, 3 pi over 2, pi over 2, negative pi over 2, negative 3 pi over 2, and negative 2 pi. Don't really need to have a mark there, but sorry. Mark where it normally is. It normally starts up, but because of the negative, it's going to start down and down. Halfway between, you're all the way up. Halfway between those, you're on your center line. Normally starts up, ends up, but because of the negative, it's starting down, ending down. Halfway between, you're all the way up. Halfway between those, you're on your center line. So here's the cosine graph. Okay, there you go. Switching to tangent. The normal tangent graph, I'm going to mark out just like we used to, or did on the other ones. I shouldn't say used to, just like we've been doing on the other ones. And negative 2 pi. For the parent tangent graph, you're going to have a vertical asymptote at pi over 2 and 3 pi over 2. Negative pi over 2 and negative 3 pi over 2. Okay. For the parent graph, I'm starting at 0. Halfway to the right, I'm going to call that 1 and -1. So -1, 1. Halfway to the right, you're all the way at 1. Halfway to the left asymptote, you're down at -1. Here's the center between your asymptotes. Halfway to the right asymptote, you're up at 1. Halfway to the left asymptote, you're down at -1. There's the center. Halfway to the left, you're down at -1. Here's the center. Halfway to the right, you're up at 1. Halfway to the left, you're down at -1. Here's the center. Halfway to the right, you're up at 1. So here's your graph. And then it hugs along the asymptote. Starts along the asymptote, comes up, hugs along the asymptote. Starts along the asymptote, starts along the asymptote, starts along the asymptote, and ends there. Okay. Same tangent graph, but it's been shifted left pi over 2. So that would be, whoops, pi over 2, 3 pi over 2, negative pi over 2. That looks like a mess. Trying to put the negatives on, and I keep putting them in the wrong spots. Negative pi, negative 3 pi over 2, heck of a pi, negative 2 pi. Normally, the asymptotes were at pi over 2, 3 pi over 2. But this has shifted it left pi over 2. So I'm going to shift the asymptotes left 90 degrees. So that means this one's going to be right down the middle. This one was here. It's now shifted to pi. This one was here. Oops, sorry, it was. There we go. It's there. This one was at negative pi, so it shifted over. This one was here. It's shifted left. Now, halfway between them, I guess I'll stay with red. Halfway between the asymptotes, you're at 0. Halfway to the right, oops, I suppose I should mark 1 and negative 1. Halfway to the right, you're up at 1. Halfway to the left, you're down at negative 1. Halfway to the right, you're up at 1. Halfway to the left, you're down at negative 1. Center, halfway right, up at 1. Halfway left, down at negative 1. Halfway, oops, center, halfway right, halfway left. So my asymptote was crooked. It should have hugged over here, so that's why I crossed it. Normally you don't cross it, but I'm compounding my sloppiness by drawing over it. Okay? I guess I missed a center point there. Apologize. So there would be your graph. Okay? So I think that's all the examples I have for you. Ooh, I got one more. Negative tangent. Okay. So, 2 pi. Here I thought it was done. I'm going to get away with it, but no. 3 pi over 2, pi over 2, negative pi over 2. Why am I always squishing this to the left? Negative 2 pi. So your asymptotes here, 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 here. I'm rushing because I hear the bell's going to ring soon. So center points are here, 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 and here. Normally you would go halfway to the right, up 1, down 1. But because it's negative, you're going to go halfway to the left, up 1, halfway to the right, down 1. Halfway up, halfway down, halfway up. Okay? Halfway right, down, halfway left, up. Halfway right, down. So so it runs along the asymptote there. It's starting at the top and running down. Oh my gosh, this one's awful. I'm rushing and I shouldn't be. Sorry about this, guys. This is looking really bad. But if I had paper to work with, I would be doing better. Excuses, I know. There you go. Okay. Whew. Okay, there's tangent. All right. Sorry, it was rushed.